In this video, I'm going to show you how to configure virtual tunnel interface, which is a point-to-point tunnel using a real Cisco demonstration lab. In this lab, I'm going to create a tunnel from R2 to R3. So the PCs connected to R2 should be able to communicate with PCs connected to R3 network like they are in a private network. Basically, the tunnel is going to create a private network across the public cloud. I'm going to ping this PC from this PC before we start the configuration and show you there is no reachability now. So we go to this PC and verify the IP address. These are actually not a PCs. These are Cisco routers, but acting as like a PC. So IP address is 10.10.2.12, and I'm going to ping 10.10.2.12. You can see it is timing out, so there is no reachability right now. As a first step, we go into R2 router and create a new IKE policy. IKE means Internet Key Exchange Policy. For time-saving purpose, I have all the commands typed up. I'm going to paste it here. So the first command is crypto ISA KMP policy 10. Let me show you what ISA KMP means. It is a protocol that establishes security associations and cryptographic keys in an internet environment. It is used to negotiate, establish, modify, and delete security associations and related parameters. ISA KMP also defines procedures for authenticating peers, managing essays, generating keys, and mitigating threats like replay attack and denial of service. That's what we are defining here. Crypto ISA KMP policy 10. We are using pre-shared key for authentication. For hash, we are using SHA-1, which is a 160-bit long key. If we use SHA-2, that will be 256-bit long key. For encryption, we use advanced encryption service 128, and we are using group 14 for ISA KMP. Let me show you a Cisco document here. This is the crypto ISA KMP policy encryption. If you go down, you have a hash, you have different groups. I will link this KB under the description. And then we have re-authentication lifetime is 1 hour, which is 3,600 seconds. So as a second step, we go to R2 router again, create a PSK, pre-shared key, and bind it to IP address of the R3 router, which is this router, and the IP address of 2. To do that, I'm going to issue the command crypto ISA KMP key. We create the key. The key name is Cisco. Address is 172.18.4.2. 172.18.4. This is 2. So now let's move on to third step. In the third step, we are going to create an IPSec transform set. So let me explain to you what is IPSec transform set is. It is part of an IPSec policy, defines the security parameters for IPSec secure authentication negotiation, including the security protocol, encryption algorithm, and authentication algorithm. So let's go to R2 and do that. Crypto ISC transform set. My set is the name. We are using ESP AES 128 for encryption transform. ESP means encryption security payload. AES means advanced encryption standard. And we use ESP SHA HMAC for authentication. That is done. Now we move on to step 4, in which we are going to create an IPSec profile and include transform set in the profile. So we are going to create a IPSec profile and include this transform set into that. To do that, we have to use two commands: crypto IPSec profile my profile. So we are naming the profile name, and then we are assigning our transform set we defined in the previous step and call it as my set. Set transform set my set. And now we are moving on to step 5, which is on R2 router. Create a new tunnel interface, configure the interface to use the IP address and the subnet of ETH00 interface, which is this interface. Specify a tunnel source, which is also ETH00, and tunnel destination is going to be ETH00 on R3 router. So let's go to R2 and I'm going to do that configuration. Interface tunnel 0, IP unnamed ETH00. I'm going to assign ETH00 IP to this tunnel 0. That's why I say unnumbered. Tunnel source also ETH00. Tunnel destination is R3 address. So you can see the tunnel is down now. Once I configure the IP, its state changes to up. In step 6, I'm going to configure IPSec as the tunnel encapsulation and specify the traffic protection policy by referencing the configured IPSec profile. So I'm going to set IPSec for tunnel encryption and specifying traffic protection policy by referencing the configured IPSec profile. That is my profile. So step 6 is done. Now I'm going to go to R2 router again and create a static route to the R3 internal network, which is going to be reachable via the tunnel. So now I'm going to move on to step 7. That is going to be a static route for R3 internal network from R2. So we can reach that R3 network via the tunnel. All the configuration has been done. So now it is a verification part. So now I'm going to go to R2 router and issue the command show crypto IPSec SA. Show crypto IPSec secure association. And you can see there are no encryption or decryption happened so far. Now let's verify the status of the tunnel interface. Show interface tunnel 0, and you can see tunnel 0 is up, protocol is also up. And now we are going to verify the routing table on R2 and make sure we have reachability to this network 10.10.20/24 via the tunnel. To do that, issue show IP route, and you can see we have reachability for that network via tunnel 0. Now I'm going to do a ping which is sourced from ETH01 interface, which is representing 10.10.10/24 network to 10.10.20/24 network. Go to this router, paste, ping 10.10.21 source ETH01. So basically we are pinging this address, which is ETH01 of R3, which is connected to 10.10.20/24 network. And you can see ping is 100% successful. So now we are going to go verify our secure association and see whether encryption decryption happened via the tunnel when we send the ping packets. Now you see encryption and decryption happened. There are 5 encryption and 5 decryption. So now I'm going to ping PC2 from PC1. We were failing before. Now I'm going to ping again and see that works or not. we lost first packet because of ARP. If you do it again, you will get 100% success. Before we do that, let's go and verify encryption decryption status. And now you see this increase to 10 and 9 because we lost one packet for ARP. That's why this is 9, this is 10. If we do again, we will get more traffic to encrypt and decrypt, 15, 14. So you will have one number difference between these two. So this is how you configure virtual tunnel interface, a point-to-point tunnel between two routers in a Cisco environment. Hope this video is helpful for you. If you like this video, give me a thumbs up. Also, please consider subscribing to the channel and turn on the notification for my future video updates.